Hi, Year 12. Here is the non-right angled trig sheet, so I'll just go over a few things with you. Here you have, if you have a right angled triangle, you're going to use SOHCAHTOA. Sine opposite hypotenuse, cosine adjacent hypotenuse, or tangent opposite adjacent. Okay, remember if you've got an angle of elevation, that's from the horizontal, going straight out, looking upwards. Angle of depression is going from the horizontal, so an arm straight out, looking downwards. Okay, for an elevation you're always looking up, maybe from the street level, and depression you're looking down from a cliff or from the top of a building, something like that. Compass bearings, remember, they start from the north or the south arm and go up or down or outwards from the north or south arm. They never go from the east or west up or down. Okay, never start from the east or west arm. Trigonometry with obtuse angles, acute angles 0 to 90 degrees will all be positive answers. That's nice and easy. In obtuse angles, you just have to remember that your sine will always be positive, but your cos and your tan will be negative. Your calculator will do most of that for you anyway. And often you have to go 180 degrees. I'll write that in. 180 degrees minus the angle to work out the obtuse, okay, or the acute of the same angle. So that's what you have to do to work out the obtuse angle. That's how you work it out. So the sine rule, we know we use this one here when we're finding a side because the side is on top. We use this one here when we're finding an angle because the angle's on top. Remember, we only ever really use two of them at a time. We don't use all three. Area of a triangle, she forgot to put that in. It's half AB sine C. And just remember, in our triangle, the angle should be in the middle of the two sides on either side of that angle. Okay, so it's got to be the included angle as it's known because it's in between the two sides. And good old cos rule, we use the top one to find a side, hence the little a. Remember, the little letters stand for sides, capital letters stand for angles. And when we're finding an angle, we use this formula when we have three sides altogether. Notice there's a little b, a little c, and a little a. And the little a is always opposite the side, the angle I should say, that we are looking for. Okay, so the side that is opposite the angle we're looking for always goes right smack bang at the end after the minus. Radial survey, usually radial means around, so that one means a survey that's going roundwards. Alright, so let's do a good old 90 degree right angled question. So if you've got a right angle, use SOHCAHTOA, okay, sine, cos or tan. First of all, I'm going to figure out, here's my angle. What have I got? I've got the opposite side, I've got the adjacent side. Okay, so now I always write out the formula first. Now I know this is tan because I've got O and A, that gives me TOA. So my formula would be tan equals opposite on adjacent. So opposite is 5.3. That goes on top. Adjacent is 1.9. That goes on the bottom. I just go in and out because it just makes it neater for me. So if I've got tan theta, remember, I have to press shift, tan, and then either 5.3 divided by 1.9. I'm going to do that on my Casio. Or I could use the fraction key. Just remember, put it in brackets if you're not getting the same answer as me. Alright, so I'm going to go shift, or second function, tan. Brackets are already open for me, so I'm going to do 5.3 divided by 1.9, close the brackets, and I get 70.2777, blah, 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 blah. And it wants our answer to the nearest minute, so I must press my DMS key or my degree minute second key. I press that once. If you don't get the answer straight away, you might need to press second function first on the sharp. So when I press what I like to call my bubble button, because it looks like all bubbles to me on my Casio, I get 70 degrees, 16 minutes, and 39.8 seconds. Remember those are the little, whatchamacallities, the symbols. Remember these are both only out of 60. So what's half of 60? You tell me, well, 30 is. Well, this one here, that one's over 30, isn't it? So that means I have to add 1 to my 16 because I've got to round it up. So it becomes 70 degrees and 17 minutes, which ends up being B. Okay, there's that one there. Alright, next one. Question number 2. This one's a little bit more convoluted. The diagram shows the location of 3 schools. Here's A. It's 5 k's due north, alright, so they've given us 5 k's, alright, that's good. Due north of school B, alright, there's B in the middle. School C, down there on the left, is 13 k's, and they've given that to us. And ABC is 135. Alright, so we know those 3 things already in the diagram, so we don't have to put them in. So our first thing we have to do is we have to calculate the shortest distance from school A to school C to the nearest kilometre. Alright, so I've got to work out this bad boy, don't I? Alright, so I have 2 sides and I've got the angle in between. 2 sides and the angle in between is the cosine rule. So I'm going to rewrite the top cosine rule. Let's write that in. So that was a squared equals b squared plus c squared minus 2bc cos A. I learned at school, the more I wrote this out, the more I remembered it. Just saved me a bit of time having a fiddle around and look for formulas. If you don't know them well enough, have your formula sheet out and just make sure you're writing the right thing down. Okay, so this one here is going to be my B, and this one will be my C, and this is going to be my capital A, okay, that I'm going to put in the formula. So I'm looking for this side, that's going to be my A squared, or my A I should really say, not my A squared. Alright, so A squared I don't know yet. B is 5. C is 13. Minus 2 times, repeat those numbers, 5 times 13 times cos of A. What was A again? It's the angle, 135. Alright, so there it is. I need to put that into my calculator. You can do this all in one go. 5 squared plus 13 squared minus 2 times 5 times 13 times cos of 135. Close the brackets if it opens, your calculator opens them. I got a squared equals 285.923 dot dot dot. Now if I'm going too fast, pause, okay? I'm just going to keep going, but if you need to slow down and write something down, just pause the video, please. Alright, what's the opposite of squaring A? Hopefully you said square root. So I'm now going to go square root answer equals 16.909 dot 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 dot. Reread my question and it says to the nearest kilometre. So that means in this case to the nearest whole number, which in my consideration 16.909 is closest to 17. So now I have this one. It's 17 kilometres. I can use that to help me with the next one. Now I'm going to do a different colour pen just so we can see. So this one says determine the bearing of school C from school A. Now operative word in bearings is the word from. What comes after from? Hopefully you said school A comes after from. So that means I need to draw a new compass rose on the dot of A, okay, or on the point of A. So it says here, determine the bearing of school C. So here's C. That's that red line anyway. It's nice there. So that means I've got to work out from the north arm all the way around to the red line. That's the bearing I need to find. Now I know that a straight line is 180 degrees, don't I? So from the north down to the south, that's 180. So I only have to work out that little angle in there. So I'm going to use my triangle. Now that I have my 3 sides, 5, 13 and 17, I'm going to use this formula. Cos A equals B squared plus C squared, and that's a minus A squared over 2BC. I need to find an angle. This is the formula I use to find the angle. So I'm going to write that down. Let's see, what was it again? b squared plus c squared minus a squared over 2bc, and cos A equals that. Alright, so the angle I need to find is where A is, so that's helpful. I need to remember though that the side opposite that particular angle, 13, oh for goodness sakes, is the one that needs to go here. Okay? Most important, you know where to put the side that's opposite the angle that we're finding. Now, what were the other two sides again? 5 and 17. So I'm going to put my 5 squared plus 17, let me get rid of that dot, squared minus 13 squared all over, and I just repeat these two numbers, 2 times 5 times 17. Now remember, if you're not getting the right answers, can you put the top and especially the bottom in brackets? Alright, so remember that's cos A equals those. So let's work those out. Alright, on my calculator, I'm going to do open brackets, 5 squared plus 17 squared minus 13 squared, close my brackets, divided by our fraction key, open brackets, 2 times 5 times 17, close brackets. I get 0.85294176. Leave that on your calculator. Don't get rid of it. Okay, you can write 0.85 on your sheet, but don't get rid of it on your calculator. How do I work out the cos of that? Hopefully you remember, you press shift and then cos. So I'm going to press shift, cos, answer, or equals if that works on your calculator. When I do that, I get an angle of 31.46697. Now this says to the nearest degree, so I can write this to the nearest degree. What's 31.466 to the nearest degree? Well, we don't change it, do we? We're actually rounding down, so it's 31 degrees. Now, is that my bearing of school C from school A? Remember, from here to here was 180, and we just worked out from there to there. So what have I got to do to the 180 and that 31 I just figured out? Hopefully you said, add them together, miss. You are correct. So the bearing is going to be found by going 180 plus that 31 we just worked out, and we get 180 plus 31, because it's getting late and I'm tired, 211 degrees T. Alright, there you go. There's the answer to that one. Alright, I'll try a couple more before I fall asleep. Here we go. 5. The diagram shows a radial survey. Now this should look familiar. Should look familiar. This was on your assignment. Okay, we need to find AOB. Here's A, here's O, here's B. You need to remember this goes from naught around that way, and it comes all the way back around to 360. So the north arm is both 0 degrees and 360 degrees, isn't it? So if we know that this is 300 to 360, then the difference between the two must be 60. And this one is 0 to 51, so that one in there must be 51. And hopefully you added those two together and you got 111 in your head or on your calculator. Remember, pause if I'm going too fast. Alright, question 6. From the top of a cliff 67 meters above sea level, the angle of depression of a buoy is 42. Now remember, angle of depression is when you're on top of something and you're looking down. So if part of the question or part of the marks is to verify where the angle of depression is, you have to remember you've got to do a horizontal line, and the depression will be from the horizontal line if that was your arm looking down towards the buoy. Remember, it is never that angle in there. Okay, so that one there is 42. Now, do we remember our Z angles from year 8 and all those other ones? 2 parallel lines when they are crossed by a second line. Remember, it creates a Z, and the crux of the Z are actually equal angles. These are called alternate angles, if you don't remember. And alternate angles are equal. So if it makes it easier for you to move that 42, and here hopefully now you can see a right angle triangle with 67 as one side. The question says, how far is the boy from the base of the cliff? So we now have to work out this length here. So what have we got? We've got from the 42, the blue one, we've got an O, and the X is now adjacent to the 42. So I've got another right angle triangle. Use SOHCAHTOA. You can use the others, but I'm telling you now, SOHCAHTOA is so much easier. And O over A is tan. So I'm going to go tan of 42 equals, O is 67, and the adjacent was X, if you remember. Do you remember what to do when the unknown's on the bottom? Quickest thing to do is to swap the unknown with the tan 42. The long way is to multiply both sides by X, and then divide both sides by tan 42 to get the X on its own. Either way, you're going to end up with this as your next step. Okay? Do that on your calculator. 67, fraction key or divided by tan 42. Now, if you've got a sharp and it's not working, can you remember to put the base like that in brackets? Press equals, and I get, come on, 74.41103849. I don't even like to write more than 2 decimal places or 3. This says to the nearest meter, so we need to round that to the nearest meter. 4 is telling me not to round up. So 74B should be my answer. Alright, let's try this one. The largest angle in the triangle below is theta. What's the angle of theta? Well, there's no theta in the diagram, but you need to know that the largest angle will always be, why did that disappear? Opposite the largest side. So that's where the largest angle will be. Notice you've got 3 sides. We need to use this formula again, okay? Whenever you've got 3 sides and nothing else, it's always that cos formula, okay? When you're finding an angle. So I'm going to write that down. What was it again? Let me think. B squared plus C squared minus A squared all over 2BC, and then I believe it was a cos A over here. Alright, so in this particular formula, my A, my 7, whatever is opposite the angle I'm finding, must be after the minus. So this one can be B, this one can be C. So that means I've got to go 6 squared plus 5 squared minus my 7 squared all over, that's a bad squared, isn't it? 2 times 6 times 5. Now remember, when you're doing that on your calculator, put the top and the bottom in brackets. So let's do that. Brackets 6 squared plus 5 squared minus 7 squared, close brackets, divided by, or fraction key, open brackets, 2 times 6 times 5, close brackets. I get cos of A equals 0.2, okay, or 1/5, they're the same thing. Right, now that's the cos of A. I still need to find angle theta, so I must press shift cos, and then, 0.2, and then press equals. So I'm going to press shift cos ants equals, and I get 78.4630 ... Read the question. Doesn't actually say whether it's a degrees or minutes, so I'll give you both. So 78.4630, if it was to the nearest degree, would be 78 degrees, wouldn't it? Or press my DMS key, or shift DMS, whatever it gives you. I get 78 degrees, 27 minutes, but I get 46.95 seconds. Now this one, remember, it's out of 60, so if it's above 30, I have to add 1 to the 27. So my final answer, if I had to give it in degrees and minutes, would be 78 degrees and 28 minutes. Okay guys, I'm going to stop there and I'll do another video soon. See ya.